Hello and welcome to a new video by YCSC Lab. In this video, I'll cover 6 must-know commands of Mona library. So the first question that I will answer is, what is Mona library? So if you are into exploit development or if you have any background of exploit development, you would have definitely come across Mona library, which is a py command for immunity debugger, and it is designed and developed to aid the exploit development process. This is one of the most popular libraries that are there to automate various tasks that an exploit developer needs to perform during this entire process. It was developed by Coder and it replaces PV find address library. The download link for Mona.py or Mona library is available in the description below, or you can just go to the link shown here and download it from there. It will direct you to the official website of Mona library, which is Coder's website. So first command that we are going to cover is how to set a working folder. So for that, Mona library provides a combination of commands, which is Mona config, which takes a flag called set and then an argument working folder, and then another argument, the path of the working folder. So as you can see here that in this case, the path is clogs %p. This %p will be replaced by the process that you will launch in immunity debugger. So every time you will open a new process in immunity debugger, Mona library will create a subdirectory with that process in the clogs folder. And if you want to further group the output of Mona library, you can use the %i variable along with %p, and this variable will get replaced with the process ID of the application that you have opened in immunity debugger. So let's see this command in action. So this is my Windows XP machine, and let me quickly open immunity debugger, and here let me set the working directory for Mona, and the command for that is Mona config -set working folder, and let's say c logs /%p. Now this clogs directory should be existing, so let me go ahead and create this directory in the C drive. I'll create a new folder here and logs. Great. So now I'll run this command, and you can see that command used is Mona this, and the old value was cmona, and now it has changed to the new value, which is c logs and /%p. Now if I open one server in it and let me use any other Mona command, so I'll use Mona byte array. So now this time it has written the output in clogs one server folder, and if you see the list of processes here, you can see the name of this process is one server. So it has created a directory with the name of the process, and if you want to further segregate it to include this PID, you can use the %i variable so that your output gets further grouped by the process ID of this particular application every time you run it. So let's go to the second command. The second command that we are going to cover is byte array command. Now during exploit development and especially during bad character analysis, you will need to generate an array of all hex characters, which is an array of 256 hex bytes. And Mona library provides a very quick way of generating that array using Mona byte array command. This command produces output in form of two files. One is text file and another is binary, that is .bin file. And it takes two flags, -b, which is if you want to exclude certain bytes from the byte array, you can use -b, and if you want to output the array in reverse order, you can use -r. Another useful command that you can use in conjunction with byte array is the compare command. So once you have sent the byte array to your application, you will need to compare it with the byte array that you have generated. So Mona again provides a quick way to generate the content of byte array in memory and the content of byte array in file using the Mona compare command. And it takes two flags. The first is -f and it takes an argument of file name. this file is where your byte array is stored on the disk. Then the second flag is -a, and the argument for it is a memory address where your byte array starts. So let's see a quick demonstration of this. I'm already in Immunity Debugger. Let me close this and let me go to the CPU window. Let's run this byte array command. Though we have already seen the execution of this command, let's run it once again. And this time, as you can see, that it has generated an array of 256 hex bytes. And if you come to the logs vulnerable directory, you can see that there are two files, bytearray.bin and bytearray.txt. This third file is from the previous file that was generated on the first run of this command. So Mona creates a backup of the previous files as well. And if you want to exclude certain bytes from this byte array, you can use -v option and you can specify hex 00. Let's say if you want to exclude the null byte, and let's say I want to exclude hex 0a also, and then if I run this command, you can see that the output does not contain hex 00 and hex 0a. Similarly, you can also exclude a range of bytes using this flag. So let's say I want to exclude the range of bytes from hex 0a to hex 0f. So this time you can see that there is no hex 00 and there are no bytes from hex 0a to hex 0f. So in this way you can also exclude a range of bytes from this byte array. The second flag that we saw was -r. That was to generate the byte array in the reverse order. So you can see that this array is the reverse of the first array that we had generated, and it starts from hex ff and ends at hex 00. You can use -b flag in conjunction with this flag also. So you can use -b and hex 00. And so now Mona has generated this array in reverse order with null byte excluded. Now let's see a quick demonstration of compare command as well. So first I'll generate a byte array in normal order and I will exclude the null byte. Then I'll go to my logs directory, which is in C logs one server, and I'll open bytearray.txt, copy this array. And then I already have a template exploit created for that run command in one server. So I'll paste this byte array here, save it, and now let's run this. So I'll open a command prompt, which is already open here, and let me navigate to desktop. Before that, I will need to run one server, and let's go to the CPU window, and here let's put a breakpoint at the jump ESP expression. Alright, now let's run python 1.py. It is given me some error, which is the variable name. So I need to change this variable name from buff to byte array. Alright, so let's give it one more try. And this time if you see in Immunity Debugger that it has hit our breakpoint. So let's step into it. This is an op padding that I had created in this part of the exploit, and this is followed by the byte array. So the byte array starts from this memory address. Now in order to use the compare command, we will type Mona compare, and I need to give it the file name, which is in C logs, and here you will need to specify the binary file, that is a .bin file. So I'll specify bytearray.bin as the file name, and address, I will specify the address where this byte array starts, which is this particular address in this case. So I'll just copy the address part, or rather let me type it out. So address is 00C0FA16. Now let's run this. So it says that it's unable to find logs byte array.pin, which is understandable because we have grouped our output with the name of the process. So I will need to specify once over here as well. And now let's run this command. So you can see that it has found the byte array at this particular address and the status is unmodified. And now if I go into the log window, you can see that the command used is this, and it has read 255 bytes from the file, and it has prepared the output in compare.txt, and it is comparing the content of the file with the content at memory location that we had specified, which is on the stack, and it has found that our shellcode has been unmodified. So there were no other byte characters except for 00, which it has mentioned that bytes omitted from input is hex 00. So that is how you use compare command in conjunction with the byte array command, and this way you can save a lot of time in doing your byte character analysis, especially when you have to repeat this process multiple times. So let's move on to the next command. The next command is tc, po and find msp. Now, another common thing that we as an exploit developer need to do is find the offset where our buffer overwrites EIP. And for that we often use a cyclic pattern. Mona library implements that feature and provides commands to not only create that pattern but to find the offset or to find the entire pattern in the memory itself using the find msp command. So in order to create a pattern, you can use Mona.py command, and it takes an argument which is the length of the pattern that you want to create. Then if you want to find the offset of the pattern, you can use Mona.py command, and it takes two arguments, which is the length and the bytes with which the EIP is overwritten. And finally, if you want to find all instances of cyclic pattern in memory, you can simply use Mona find msp command. And if you want to set the distance from ESP to begin the search from, you can set it using the distance flag. So let's see these commands in action. So let's say I want to create a pattern of 3000 characters. So I'll use Mona.py and 3000. So you can see that it has created a pattern of 3000 bytes and it has written it into a file called pattern.txt. So we go to the log directory, which is this, and here you'll see a file called pattern.txt. So let's open this file. And in this file, Mona has created output in two formats. One is ASCII and another is hex. So you can use either of the formats, and it has also created an output in JavaScript format. So it makes it really convenient to use these patterns at multiple places. So I'm going to go ahead and copy the ASCII format, and in my template exploit, I'll replace this and I'll just delete this entire string. And in the evil string, I'll replace this entire string as well with the cyclic pattern. And now let's restart the server. And let's run this command again. So you can see that an access violation has happened when executing these bytes. So these are the bytes with which EIP has been overwritten. Let me just copy this to clipboard. And now in order to find the offset, you can simply use PO and the bytes. Looks like it does not take the length character. Let me just try it with the bytes. So here you can see that this pattern has been found at position 2002. And if we come back to our template exploit and just if I do undo, you can see that we had already placed 2002 A's here, and this is the address of jump ESP instruction with which we had overwritten EIP. Now another quick trick to find all instances of the cyclic pattern is to use the Mona find MSP command. So you can use Mona find MSP, and it will tell you the offset of all the instances of the cyclic pattern. And you can see that it has found this cyclic pattern at 3 locations here, and it has also found this pattern at EIP and EBP, and it has also found this pattern on stack, and these are another 3 locations at which this pattern was found. So this way you can check if your pattern occurs in multiple locations, and this is really helpful where you have limited buffer space and you want to find if any part of your buffer has made it to any other segment in memory. So you can use find MSP for that purpose. So let's move to the next command. So the next command is Mona egg command, which is to generate an egg hunter routine, and it takes these optional arguments. You can use -t to specify a custom tag of 4 bytes, 4 or more bytes actually, and then you can also use -f argument to specify a file containing shellcode. And if you specify this option, Mona opens that file and then prepends your shellcode with this tag twice. And then if you want to enable the checksum routine on this shellcode, you can use that with -c. Now do remember that you can use -c flag only in conjunction with -f flag. You cannot use it independently of -f. So if you're dealing with exploits that need to bypass dep, so Mona provides arguments for that purpose also, and these are the 4 arguments: dep method, dep register, dep size, and dep destination. So let's see this command in action. So I'll generate an egg using Mona egg. First, let's do it without any argument or without any flag. So without any flag, by default Mona uses W00T, that is woot, as a default tag. And if you want to customize this tag, you can use -t option, and you can specify the custom egg or tag. So I have specified YCSE here, and let's run this command. Now as you can see here that the egg has been set to YCSE, and this egg hunter routines contains this YCSE tag. And Mona has also written this egg hunter routine in egghunter.txt in the logs directory, which is this. So if I just refresh this directory, you can see that there is an egg hunter file which contains our egg hunter routine. And it also tells us that we need to put this tag in front of our shellcode. And if you specify your shellcode file with the -f option, Mona can do that automatically for you. Moving on to the next command. The next command in this series is jump command. During the process of exploit development, many a times it will happen, especially if you're exploiting plain stack overflow, that you will need to find a pointer to jump instruction, which will lead the EIP to jump to a particular register. Now, in order to find the pointer to that sequence of jump register instruction, Mona provides a command called JMP, and it takes one flag, which is -r, which takes one argument, which is a register name. Now by default, Mona skips ASLR and rebase modules. However, if you want to override this, you can use -cm flag, and it takes one argument, which is OS equal to false. So let's see this command in action. So here, if I write Mona and jump, and let's say I want to find the pointer to jump ESP instruction, so I'll specify R ESP. So it will search across all modules that are non-ASLR and non-rebase and list down address of all the memory addresses that contains jump ESP or equivalent instructions. So it has returned, and let's see the log window now. You can see that Mona has found jump ESP instruction at these memory locations, and it has found a total of 35 pointers, but it is showing only first 20 pointers. Rest have been written into a file called jump.txt in our working folder, which is this. So here there is a file called jump.txt, and if you want to see all pointers, you can open this file and see the entire list of pointers that Mona has found. Similarly, Mona also provides command to find a pointer to pop-up return instruction, which is often used when you are writing exploits to overwrite SEH chain. And the command for it is very simple, which is Mona.py, and by default it will attempt to bypass the safe SEH flag by excluding pointers from rebase, ASLR or safe SEH protected modules. However, if you want to include all pointers, you can use the -all parameter or the -all flag to search for pointers across all memory location, even outside of the loaded modules. So let's see this command in action. So here is my emulator debugger, and if I want to find that pointer of pop return for my SEH overwrite exploit, I'll just have to write Mona.sh, and it has returned the location of these pointers. So these are the memory locations that Mona has returned, on which you can find the pop return sequence, and it says that it has found a total of 18 pointers, and all of these 18 pointers are shown here. Now this output also will be written to a file called sh.txt, which you can find in the working folder of Mona. So you can see this file. In case there are more than 20 pointers, you can open this file to check the list of all pointers that Mona has generated. And now let's try this command with all flag or all parameter, and let's go to the log window, and this time you can see that Mona has found a total of 19 pointers. So I was expecting a bit more of output, but that's not a problem. At times it might happen that you may have similar or less output than you have expected. That happens often in exploit development, so be prepared for that. So anyways, Mona has returned this list of pop return instructions, and you can see here that it has also returned a pointer to call instruction, which in a sense acts in a similar way as the pop return sequence. So if feasible, you can use this instruction as well in your SEH overwrite exploits. So these were the 6 Mona commands that I regularly used during exploit development. If you have any other command that you regularly use, or if you would like to suggest another command that should be included in this list, do let me know in the comments, and I will create a video with that command as well. If you have any further questions or you need any further support, you can reach out to us on csc@yakshas.io. If you are interested in learning the art of exploit development, you can check out our hands-on courses. We have 2 courses in this series, and these courses together cover various techniques such as Stack Overflow, Egg Hunters, SEH overwrite, ASLR bypass, stack pivoting, short jump, long jump, and banner encoding, how to deal with limited buffer space, how to deal with limited character space, and much more. You can also check out our free course, which is Emulator Debugger for Exploit Devs, and it is one of our essential courses, hence it is free. If you want to gain an in-depth knowledge of Emulator Debugger, do check out this course. So if you're interested in enrolling in our paid courses, you can use the coupon code NEXTSTEP to enroll at INR 640 each. That was it for this video. You can subscribe to this channel. You can also check out our website, and you can follow us on Twitter. Our Twitter handle is @yakshas443. Thank you for watching this video, and I'll see you in the next video soon.